Through space exploration, we continue to propel ourselves along the path of knowledge and comprehension. By studying comets, we may unravel many questions about the early history of our sun and solar system. Although we cannot travel back in time, comets could enable us to peer into the past and further our understanding of the universe.
We think that comets are leftover material from the formation of the solar system. And in fact, that's one of the reasons that they're so interesting, that maybe by studying comets, we will find out something about the origin of our solar system. If you look out into space between the stars, you see a very large amount of cosmic dust, very small particles, a few microns, a few millionths of a meter on a side. We believe that at times there are dense clouds of material out in space that begin to contract. And as they contract, the gaseous material freezes out on these particles. And through a long chain of processes, it winds up into forming a solar system like our own. And some of these icy materials that are very far from the central star of the solar system remain and form comets and planets like Uranus and Neptune, which are cold, icy planets. The material that was formed nearer the star, in our case the sun, the icy material is boiled off, leaving behind just the little particles which form the solid planets. Basically, a comet is a big chunk of ice that is orbiting around the sun in an orbit that can take it anywhere from the shortest known period of about 3.3 years up to periods well in excess of 10 million years. Typical sizes for these chunks of ice are of the order of a few kilometers. Halley's Comet, for instance, the main body of ice is like 5 kilometers in diameter. There are a lot of interesting phenomena that you see in the nuclei of comets, jets and eruptions and things of that sort. As that block of ice moves close to the sun, the heat from the sun causes all kinds of interesting things to happen. It causes the icy materials to sublimate, which means to go from the solid to the gaseous state, and a large halo of material forms around this small nucleus of the comet. That halo can be anywhere up to 10 times the diameter of the Earth. And then the effects of sunlight and the solar wind acting on the electrified material, the plasma in that coma, that halo of material, causes the tail to occur, which always points away from the sun. And so basically, a comet consists of 3 parts: that solid, icy nucleus, and when it's in the vicinity of the sun, this very large coma, which can be up to 10 times the size of the Earth, and the tail, which can be many millions of miles long, up to 100 million miles. Many of the comets that we observe have 2 types of tails. One of them we call a dust tail, one of them we call a plasma tail. And the processes by which they're formed are quite different. The plasma tail of a comet is made up of just that, plasma, a gas made up of electrified particles. That plasma tail always points directly away from the sun. The process that causes that is the solar wind. The solar wind is also plasma. It's plasma that moves away from the sun at a very high speed, up to 800 kilometers a second. And as that plasma from the solar wind sweeps by the plasma in the comet, it forces that, just like a windsock, to point away from the sun. And if you see a color picture of a comet, the plasma tail tends to look blue. The dust tail, on the other hand, is made up of all these little dust particles that were released as the ice is sublimated. when the comet leaves the solar system, it leaves tail first, because that's the direction away from the sun. Comets are members of the solar system, and we have no evidence to indicate that any of the 1,000 or more comets that we've observed in the past are not members of the solar system. There are some comets that appear to move in an orbit that is hyperbolic. Now, what that means is that they're moving in an orbit that is not closed, and they're not bound to the solar system, apparently. But the hyperbolicity of the orbit is very, very small. And our conclusion that they're hyperbolic is more a matter of observational error than of their being truly hyperbolic. So our conclusion up to the present time is that all comets are in fact members of the solar system. What is the difference between a comet and a meteor? If you were to see a meteor in the sky, it's a very brief flash of light that might last for a small fraction of a second. A comet, on the other hand, when you see it at any given time, is stationary in the sky, appears to be stationary in the sky, because its motion is relatively slow. And you'll see it from night to night for a period of weeks, perhaps, rather than just for a matter of seconds. A comet is fairly far away from the Earth, probably way beyond the moon, whereas a meteor is actually a small particle of material burning up in the Earth's atmosphere. Comets have always been a cause for superstition over the years. And every time a comet appeared, they expected something bad to happen. And the fact of the matter is that when a comet appeared, something bad always did happen. Of course, what people forgot is that when a comet wasn't around, something bad was happening too. So the comet, I think, tended just to be a scapegoat for the bad things that were happening at that particular time.
Comets have been recorded in art through the ages. In art, comets have been associated with good as well as evil.
And comets have long played a prominent role in art. I think one of the most beautiful pictures of a comet is in Giotto's famous painting, The Adoration of the Magi. And that particular painting is important to the art historians, and it's also kind of important to us today. The Star of Bethlehem in that picture looks very much like a comet. And it just so happens that a year or so before Giotto made that painting, Halley's Comet was in the sky. And the Star of Bethlehem looks so much like we think Halley's Comet would have looked at that time, that the art historians thoroughly are convinced that he used Halley's Comet as the model for that particular drawing. The history of our understanding of comets is extremely interesting, and of course one could extend the story very far back into history. Aristotle, the famous Greek, did a lot of studies of comets, and of course he thought that they were things taking place in the Earth's atmosphere, fiery exhalations in the Earth's atmosphere, until say around the 16th century. The feeling was that comets were part of the Earth's atmosphere. And then Tycho Brahe tried actually to measure the parallax of a comet, and he was able to take observations that were made in various places in Europe, actually show from those observations that the comet was actually beyond the moon. Now, there's no way that the comet could be beyond the moon and in the Earth's atmosphere at the same time, and therefore Tycho demonstrated, in fact, that comets are celestial objects. That settled the matter for a while, and then Isaac Newton, in the late 17th century, came up with a technique for estimating the paths that comets follow through the sky. And a contemporary of his, by the name of Edmund Halley, decided that he would use that technique that Newton invented to come up with the orbital paths of a number of comets that he had good observations for. And he did that, I would say, for about a dozen comets that had been observed over the centuries up to that time. And he discovered something very interesting, that about 4 of those comets seemed to move in the same path. Now here, very interesting, 4 comets moving in the same path, But even more interesting, the interval of time between which they were observed was about 75 years. And Halley looked at that data and said, gee, I'm looking at a comet that is moving in a very elliptical orbit in the solar system, and it comes back about every 75 years. Well, Halley passed away before the comet returned. But sure enough, within a few months of the time that Halley predicted that it would be in the sky, it was there. The comet, in honor of that, was named Halley's Comet and has carried that name ever since. And so Halley's Comet not only is an interest as a comet, but it is also of interest because it demonstrated the validity of Newtonian theory. Since comets sublime as they pass near the sun, they're going to lose some of their material as they pass by. And Halley, for instance, is certainly going to lose a few meters of its diameter, perhaps even a few tens of meters of its diameter, every time it passes near the sun. What that means is that a comet like Halley has a finite lifetime. If the nucleus is only about 5 kilometers in diameter, and it loses a few meters or even tens of meters as it passes by, a simple arithmetic tells you that it may last only a few thousand passes before it disappears.
Just as planets orbit the sun at different periods of time, individual comets have different periods of revolution around the sun.
The difference between a long-period comet and a short-period comet is somewhat more than just the periods. If you look at the numbers of comets that have different periods of revolution around the sun, they range from between, about 3.3 years for Encke's comet up to 10 million years. There is a fundamental difference in the types of orbits that these comets have. For instance, comets, long-period comets with periods like 10 million years, can appear anywhere in the sky. But the short-period comets, like Halley, tend to occur more likely in the ecliptic than just anywhere in the sky. Can a comet hit the Earth? You know, that's an interesting question, and there's a little bit of controversy on that right now. Well, somewhere around the beginning of this century, an object hit the Earth in Siberia, and it blasted a great big hole in the tundra. A group of scientists found the impact point, and they found something very interesting, namely a forest that for many square miles had been knocked down, and all the trees were pointing radially away from the impact point. And at the impact point was a great big hole in the ground. Now, what's interesting about it is nothing was found of whatever caused the impact. There is the forest torn down, there's the great big holes, and nothing else. Well, there were all kinds of ideas, that it was an alien spaceship hitting the Earth, that it might have been a miniature black hole hitting the Earth. But recently, the suggestion was made that it was actually a chunk of a comet that smashed into the Earth. And in fact, it never really hit the ground, but it blew up a mile or so above the surface. And that is exactly what you would expect of something frail like a great big chunk of ice like that.
Comet Halley will be studied in more detail during this encounter with the sun than any comet in the history of humankind. Observations will be made from space and from the Earth.
The participation of the United States in that is going to be twofold. One is to launch a mission into orbit around the Earth to study the comet. And another one, which I think is extremely important, is called the International Halley Watch. Basically, through the good offices of NASA, this International Halley Watch has signed up a large number of observatories all over the world to study the comet. And there are a number of different networks of observatories. One that will do imaging, one that will do spectroscopy, one that will measure the brightness of the comet, do photometry as we call it. And so we've got this worldwide network that's going to collect scads and scads of data. Now, what's important about the worldwide network? What is important is that we will see the comet 24 hours a day. This is the first time we have ever set up a network where some observatory will be observing the comet whenever it is above the horizon at that site. We've got 100 observatories, nearly 100 observatories around the world that are going to be doing all kinds of observations of the comet. We're going to have a series of observations in time, motion pictures covering the entire motion of the comet while it's in the sky and bright. It's just hard to predict the tremendous observations that we're going to have. This is an area where amateur astronomers can help, and that is that collecting observations, if they see anything unusual happening on the comet, to somehow get that data to the International Halley Watch. And it might very well be that they have seen something that the professional astronomers haven't, and it could be very important in the overall study of the comet. There are a number of missions going on right now to observe Halley's Comet from space. And let me just describe a little of these. 3 of the missions are actually going to go out to the comet itself and fly near and carry out close-up observations. One of these missions has been flown by the Japanese government, another by the Soviet government, and a third, which was named after Giotto, who painted the famous Adoration of the Magi, being flown by the European Space Agency. All of these are on their way toward the comet now, and I expect when they pass near the comet, which I guess will be in March and April of 1986, that we're going to see some very spectacular photos of the comet. So that's going to be one of the most exciting parts of it. But in addition, there are going to be a number of other very interesting scientific ventures carried out, including trying to capture some of the cometary plasma and analyzing it, capturing some of the cometary dust and analyzing it. It would really be nice if we could capture some of that and bring it back, but all of that analysis will have to be done remotely in laboratories that are aboard these spacecraft. The United States is also planning a space venture to the comet, but it's going to be a space venture from Earth orbit. And this is a mission called the Halley mission. ASTRO is basically an astronomical observatory that will be sent into space to study stars in various ways and other celestial objects. But it just so happened that the timing was right for it to be in orbit in time to observe Halley. And so in addition to the other astronomical instruments that are going to be on board, there are going to be 2 wide-angle cameras, simple Hasselblad cameras with wide-angle lenses. And they will be used to take wide-angle photographs of the comet. And we feel that those photographs will be an important adjunct to the close-up photographs that will be taken by the spacecraft that are flying through the comet itself. To the best of my knowledge, we are still planning to observe Halley with the Solar Maximum mission. It turns out that the reason that we're going to have a hard time observing Halley this time, you and I, the general public, is that when it is at its absolute brightest, it's going to be on the opposite side of the sun from the Earth. And so it's going to be lost in the glare of the sun. But it just so happens that the Solar Maximum mission was designed for observing the sun and the very faint corona just off of the edge of the visible sun. And so some astronomers came up with the good idea of applying that capability of looking far enough off to see Comet Halley itself. And studies on exactly how that can be done are underway. Comets tend to be named after the individual that discovered them. If you, by any luck, were to go out and, in the process of sweeping the sky, observed a new comet, your name would be attached to that comet. If at the same time someone else discovered it too and sent in a telegram to the International Astronomical Union Central Bureau for Comets, which is in Cambridge, Massachusetts, and the telegrams got there more or less at the same time, both names, or up to 3 names, might be attached to the comet. Now, there are a couple exceptions to that. Halley's Comet is a good example. Edmund Halley did not discover the comet. It had been seen by a lot of other people before he ever saw it. But he is the first person to show that it was traveling in an orbit around the sun. And in honor of that great feat, the comet was named after him. What is it like to see a comet? That is absolutely fascinating. Usually, comets are only seen in the early morning or late at night. And as luck will have it, some of those early morning comets come in the middle of the winter. So you might have to get up at 4 o'clock in the morning and go stand in the freezing cold just before the sun comes up to look over near where the sun is going to come up to see the comet. But generally, if you do that, you're going to be in for a very worthwhile experience. A Comet West is a very good example of that, which was observed a few years ago. And it could be seen near where the sun was going to rise, the tail extending a significant fraction of the way from the horizon to the zenith, and the coma, the head of the comet, very near the horizon. It's a glorious sight. Generally, what you see is the dust tail of the comet, so it's all very white, but it's a very extended, large object observed on the horizon. Just absolutely glorious. Unfortunately, Halley's Comet is going to be somewhat difficult to observe this time. We have one little bit of bad luck, and the little bit of bad luck is that when the comet is closest to the sun and brightest, it's going to be on the diametrically opposite side of its orbit from the Earth, and we're just not going to be able to see it then. When we will see it are two times, as it's approaching the sun and the Earth, when the Earth will be a little closer to the comet, and then later on when the comet is leaving after its approach to the sun, and the Earth will be a little bit nearer at that time. There are, as I say, there are two times when we can see the comet. The first of those times is in the first couple weeks of December 1985, and that is a very favorable time for people in the northern hemisphere to see the comet. It won't be exceptionally bright, but it should be bright enough to be seen if you do two things. Get yourself a pair of binoculars and get away from the city. My fear is that most of the people in the northeastern United States, if they don't get outside of the cities, are never going to see the comet. You must get away from the light pollution and air pollution of the cities, out into the countryside, and I think you have a fairly good chance of seeing it. Now, the second time that it's going to be observable is in the first couple weeks of April of 1986. Unfortunately, the comet during that time is going to be very far south. So if you want to observe the comet then, you have to go south. Now, most of us aren't going to be able to trundle off to South America where it would be most easily observed, but just getting a little bit further far south in the United States, a trip to Florida in April would be quite nice to see the comet. But the first thing, if you can't do that, the first thing to remember is to get away from the cities, out into the countryside, away from the lights and away from the pollution. If you buy yourself a big telescope and use high magnification, you're going to spread that image out even more, and you're going to decrease the contrast. And the fact of the matter is that I suspect that someone looking at the comet with a big telescope and high magnification won't see it. But if you get yourself a good pair of binoculars with, a 7 by 50 binoculars would be absolutely perfect, because they are perfectly designed for looking at faint objects. And I think they have enough power and enough light gathering capability that you would be able to see the comet very well with them. What should the general public look for in the comet? There are actually a number of events that take place in a comet that are visible, and these are changes in the head of the comet very near the nucleus. You can see jets and arches, actually small structures moving around, and it would be interesting to keep a record of that. It's also, I think, fascinating just to observe the comet's motion from night to night. Try to find the brightest part of the comet and see where it falls among the stars and plot it on a star chart. And from night to night, you could actually see the motion of the comet and get some feeling for the rapidity with which it's moving. And then think to yourself how an astronomer can take 3 or 4 observations like that and actually ascertain everything there is to know about the path, or much of what there is to know about the path of the comet through space.
As Comet Halley returns, people around the world will share in its scientific and visual wonderment. This famous comet will not appear again until the year 2061. So as we prepare to see and study the comet, we must remember that for most of us, it is truly a once-in-a-lifetime opportunity.